What's up, everybody? Today we're covering USACO's 2022 January contest at the bronze level. Problem number 2, non-transitive dice. To pass time in the barn, the cows enjoy playing simple dice games. One of these games is played with 2 dice, X and Y. So dice X and dice Y. Both are rolled, and the winner is the die with the highest number showing. Fine, so if X is 3 and Y is 4, then 4 is greater than 3 and Y is the winner. If both land on the same number, they are re-rolled. They may be re-rolled several times as long as there continues to be a tie. We say die X beats die Y if it is more likely that X will win this game than Y. Okay, so the dice are going to have different faces. We can see, consider the following four-sided dice. Die A has the numbers 4, 5, 6, and 7 on its sides. Die B has the numbers 2, 4, 5, and 10 on its sides. And die C has 1, 4, 8, and 9 on its sides. So let's write these out here real quick. So I've got A with 4, 5, 6, and 7. I've got B with 2, 4, 5, and 10. 2, 4, 5, and 10. And I've got C with 1, 4, 8, and 9. 1, 4, 8, and 9. And they say that a die beats another die if it is more likely that it's going to win. So what that means essentially, in order to know when a die is more likely to win, you basically have to compare every face against every other face. So let's compare die A versus die B. 4 versus 2, A would be the winner in that case. So that's a point for A. 4 versus 4, that's a tie, so we ignore that. 4 versus 5, that's a win for B. 4 versus 10 is another win for B. 5 to 2 is a win for A. 5 to 4 is a win for A. 5 to 5 is a tie. 5 to 10 is a win for B. 6 to 2 is a win for A. 6 to 4 is a win for A. That's 5. 6 to 5 is a win for A. And 6 to 10 is a win for B. Finally, 7 to 2 is a win for A. 7 to 4 is a win for A. 7 to 5 is a win for A. And 7 to 10 is a win for B. So my final score here is going to be, looks like 9 versus 5. So comparatively, B is able to win 5 of the rolls. A is able to win 9 of the rolls. Let's look at B versus C. So in this case, A is the winner versus B. So we'll clear this up, clean this up, clean that up. Looking at B versus C, I have 2 to 1, that's B. 2 to 4, that's C. 2 to 8, that's C. 2 to 9, that's C. 4 to 1 is B. 4 to 4 is a tie. 4 to 8 is C again. 4 to 9 is going to be C again. Is that 5? That's 5. 5 to 1 is going to be B. 5 to 4 is going to be B. 5 to 8 is C. 5 to 9 is C. And then looks like B is going to win on all these. 10 to 1, 10 to 4, 10 to 8, 10 to 9 is going to be 4 more wins. So 1, 2, 3, 4. In the end here, I have 5, 6, 7, 8 versus it looks like 5, 6, 7. So again, B can beat C in this case. So B is better than C. But something weird is going to happen when we compare C to A. You would think intuitively that one die would be a superior die. And that would just be the case, like the dice would have a score. When you were to look at something, for example, if it's something that you compare linearly, like height. If I have A, B, and C. If A is shorter than B and B is shorter than C, then it should stand to reason that C should be taller than A because of the transitive property. And that's why this is called non-transitive dice, is because these dice don't follow the transitive property. The transitive property generally is stating that if A is greater than B and B is greater than C, that you can conclude that A is greater than C because B is larger than C and smaller than A. So using that B as a comparative middle point would allow you to conclude that the larger thing is larger than the smaller thing. These dice aren't going to follow that rule. And the reason why is kind of hard to explain and not necessary for this problem. You can kind of fiddle around with this and see if you can get a feel for it, but generally it just has to do with the distribution. What's going to happen is A is somewhat centered. 4, 5, 6, 7, those are kind of in the middle, whereas B and C both are more and more spread out. In the case of B, I've got 2, 4, 5, and 10. It's kind of together, but then there's still one outlier here. And then with C, I have very spread out with low and then 2 fairly high numbers, but these 2 high numbers are both smaller than this high number here. So just for whatever reason, this is going to be the case where C is actually going to beat A. Let's write that out and show how that works. 4, 5, 6, and 7. So once again, A with the moderate die faces. So C to A is a win for A. I'm going to write these down here where I have more room. C to A is a win for A. Here, this is a win for A again. That's a win for A again. That's a win for A again. So A is going to win on all the comparisons against 4. A is going to win on the 5, 6, and 7. So that's another 3, 1, 2, and 3. And then C is going to win on both 8 and 9 for all 4. 8 to 4, 5, 6, and 7, and then 9 to 4, 5, 6, and 7 is all going to be wins. So that's going to be 8 over here for C, and then A had 5, 6, 7. So C is greater than A. And again, you don't really have to understand why this is the case to solve this problem, but it is a fairly interesting property. It's kind of fun to fiddle around with. The reason why that came out the way it did is because the 8 and the 9 essentially lost to the 10, but then both of those were able to beat everything with A. And the reason A was able to beat B was because A was fairly centered and a lot of the B faces were smaller. 2, 4, and 5 were smaller than, in general, smaller than 4, 5, 6, and 10. So the 10, while this was really effective against C, was not so effective against A. And then also because C had some lower numbers, B was able to, despite the fact that B had lower numbers, it still kind of was superior. So anyway, you don't have to worry exactly why that happens, but it is a fairly interesting property. So these are non-transitive dice. A is able to beat B, B is able to beat C, but then C is able to beat A. These dice satisfy, and then we're going to read about it. These dice satisfy a rather intriguing property. A beats B, B beats C, and C also beats A. In particular, none of these 3 dice is the best, beating the other 2. In this case, when no two dice tie and no single die is the best, we call the set of the 3 dice non-transitive. In a non-transitive set of 3 dice, each die beats one other die and loses to another die. Given the numbers of the faces of the 2 4-sided dice, A and B, please help the cows determine whether there is a way to assign numbers to the faces of the 3rd die, C, so that the set of dice is non-transitive. So they will give you A and they will give you B, and you have to figure out, is there a C? Not exactly what C is, but just whether or not there exists a C that could do that. And again, a lot of students got trapped into trying to figure out the logic behind this, and ended up timing out trying to understand logically how to generate die C. But reading about the limitations, this is another one where looking at the limitations is extremely important. Let me see. Given the number of faces of the 2 4-sided dice A and B, please help the cows determine whether there is a way to assign the number of the faces of die C such that the set of the dice is non-transitive. The number of the faces on all die must be integers in the range from 1 to 10 inclusive. Now, this is the most important part of this problem. Because of the fact the range is 1 to 10 inclusive, because of the fact we have 4 sides, then if you think about that, I've got 4 sides, each which can have 10 possible values, which means there's only 40 possible dice that can exist. 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 1, 3, 1, 1, 1, 4, up to 10, and then 1, 1, 2, 1, 1, 1, 2, 2, 1, 2, 3, and so forth. Now, that's only 40 dice, which means all we need to do, really, in order to figure out die C, is just try all 40 dice. If you have a way to generate all of the possible dice that can exist, then you can compare that die directly against A and directly against B, and look for a die that will create that transitive property, and just test all 40. Let's look at the input-output, and then I'll give you some tools to make that easier to do. Each input consists of several independent test cases, all of which need to be solved correctly to solve the entire input case. The first line of input contains T, 1 through 10. So this is another one with a bunch of test cases. And again, I think I've mentioned this in some other videos, but the best way to deal with these test cases is in your main, assuming you're in Java or C++, just make read in whatever your T value is from input, and then just make a for loop that goes from from 0 up to T or whatever. And in there, call a solve function. And then do all of what you would usually do in your main function in your solve function. And then this just solves one test case. So your main is only responsible for calling the solve function the correct number of times. Your solve then is actually going to do the reading of one single test case, the solving of one single test case, the output of the result of one single test case, and then the main will just call that a bunch. If you're doing Python, you can just define the solve function, and you probably are not making a main, but at the bottom, just have a loop that goes from 0 up to however many test cases and call your solve function. Solve function doesn't need to return anything, just treat it like a void function. It reads the input, solves the problem, outputs the result, and then you can focus on writing solve first with just a single test case. And then once you get it working with just the input for a single test case, then your main can loop through and call the solve function as many times as necessary. All right, so output format, print to the output terminal. So all this is just coming in from the terminal and printing out to the terminal, no fancy file readers or anything. Please write T lines of output. The kth line should be yes if it's possible to design a die C to make the kth test case into a set of non-transitive dice and no otherwise. Great, so in this example, this one was right out of the sample they gave us above, 4, 5, 6, 7, 2, 4, 5, 10. And just in case it's not clear, what that is the first 4 faces is die A, second 4 faces is die B. In a lot of problems, they tell you like how many pieces of input there's going to be. There'd be like for example, an 8 to indicate 8, and then like 4, 5, 6, 7, 2, 4, 5, 10. But because all the dice are exactly the same with 4 faces, we don't need to have this. So they've left the line out that tells you how much to read. You just have to know that you're going to be reading 8 numbers. So as far as organizing this, what I would recommend doing is I would recommend having some sort of a compare function, that takes in some sort of an array, or list or array list or vector or whatever you're comfortable working with. But we need some sort of a structure that can have 4, 5, 6, 7, for example, and then some sort of a structure that can have 2, 4, 5, 10. And this needs to return true, or let's not even call it compare, let's just call it wins or better or bigger. What did they call it? They used a word in here. Let's just call it better, it doesn't really matter. So if we have a function called better, for example, that takes in an A, which is just a list of 4 sides, and a B, which is a list of 4 sides, essentially all you need to do is make a for loop for I from 0 to 4, for J from 0 to 4. If die A at I is greater than die B at I, then you'll do like A score plus plus. Otherwise, if AI is less than BI, then you'll do B score plus plus. Basically, anytime the value of A's face, sorry, this should be J, B at J and B at J. So comparing A at I versus B at J, and then A at I versus B at J in your list. If A is strictly larger and not equal, then that's a point for A. If B is strictly larger and not equal, that's a point for B. Once you get done, if A score is bigger than B score, then we're going to return true. Otherwise, if B score is bigger than A score, we'll return false. What that essentially is going to give you is a function here that will take in 2 dice, A and B, and then tell you whether or not A is able to beat B. What you're then looking to do in your main solving section is basically for face 1 from 0, or sorry, from 1, 1's the smallest face value. For face 1 from 1 to 10, for face 2 from 1 to 10, for face 3 from 1 to 10, for face 4 from 1 to 10. And again, nesting all those for loops might feel a little awkward, but since it's only 1 to 10, again, there's only 40 possible die. There's other ways to generate this, but this is going to be the easiest way to do it. So you have a for loop for each face from 1 to 10, for each face 2 from 1 to 10, for each face 3 from 1 to 10, for each face 4 from 1 to 10. Basically, what you're trying to look for is you want to find one where better A, comma, that list, F1, comma, F2, comma, F3, comma, F4 is equal to true, and better. So if A, actually this should be, and not better, B, comma, I'm writing this in an awkward way. I'm going to rewrite this in a second. For F1, F2, F3, F4. Basically what you're looking for is a situation where A is better than this die and B is not better than that die. There's ways you can optimize this. Let me actually kind of drill into this logic a little bit. So if I have die A, die B, and then we'll do die C is going to be equal to those faces. Face 1, comma, face 2, comma, face 3, comma, face 4. Then we've got our 3 die. And again, this is just going to be the internal parts of the for loop. So all the way when you're four steps in the for loop deep, you have your die A and die B that you read from your file. You have your die C that you just built out of the faces from the for loop. And now what we're going to do is we're going to say, okay, so if better A than B, then if also better B and C and better C and A, then we want to just see out or print rather. We want to output to the terminal the word yes, and then just return. If you're doing this in that solve sub function, you can just return and get straight out of the function, even though you're in the depth of an if statement instead of a bunch of for loops. You can just write return. Don't return anything, just return by itself. You know, in Java, C++, and Python, all the languages work the same. If you just put return and you don't return anything in a void function, it just exits the function immediately. So if it is the case that A is better than B, then we want to make sure that B is better than C and C is better than A. And if so, we output yes. And if not, we just keep looping around. On the other hand, if it's not the case that A is better than B, that implies that B is better than A. So then what you're going to do is in your else, you're checking to see if better, I guess if not better, B, C, and not better, C, A. Or you could just reverse the order and say better C, comma B, and better A, comma C. Then again, you want to print yes to the console, yes, and then return. If we get all the way through all of our for loops and we make it all the way to the bottom and nothing printed out yes or returned, did a return, then that means that no die was found, which means that down here you can print out no. So just as a general structure, kind of starting this over, you're going to read this in as die A, you're going to read this in as die B, you're going to make four for loops deep to create die C, and we'll try every possible die C. If A beats B, then if also B beats C and C beats A, then you're going to output yes and do return to exit the function. If it's the other way around and A loses to B, then we want to make sure that B loses to C and C loses to A. And if that's the case, you would output yes, and then return out of the function. Finally, if you make it through all four of those for loops and you get all the way down to the bottom of that function and no die was found where that rule holds, then you can conclude that they're not transitive dice. You output no, and then that'll be the end of the function. So that's the general structure. Good luck coding it, and I will talk to you in the next one.